So today's agenda, we've had the partner and Snowflake introduction, and then we're going to do the Zero to Snowflake hands-on lab. So we're going to prepare the lab environment when we get the scripts and the guide, and then we're going to talk through the Snowflake UI, and then we're going to create some objects, so databases, tables, external stages, and some file formats. And then we're going to work with some compute resources, so we'll resize, create, and use some warehouses. Then we'll talk about multi-clustering in Snowflake. And then we'll also run some queries on some semi-structured data. We'll learn about results caching in warehouses and do some zero copy cloning. We'll also look at some RBACs, so role-based access control. And then at the end, hopefully have some time for a wrap-up and a Q&A. But essentially, what is Snowflake? So Snowflake is a data warehouse as a service, and it was built for the cloud. So all data is centralized and shareable, so we have semi-structured and structured data in one place. It's unlimited, automatic and can scale up in speed, so we can call the compute when we need it for on-demand workloads. It's simple and cost-effective, so we can tell warehouses or compute resources when we want to use them. We can tell them to resume, we can tell them to stop at a click of a button. And all of this is wrapped in a services layer, which makes us data guys just focus on the data. So it's faster and better in decision making. So let's talk a little bit about the architecture. So the compute, storage and services are all separated out. And we have this cloud agnostic layer. So you can see that we can sit this on either Google, AWS or Azure. And then we have this centralized storage where all of our non-structured or structured data or semi-structured data can live. And then we also have the extra layer of this multi-cluster compute where we can call a compute at any point to execute on our shared data sources. Then wrapped around that, we have all these services. So we have these scale-out services, for example, optimization. Snowflake has its own built-in query performance. We have the management, so we have the whole GUI interface that we can interact with Snowflake. And then we can see all the transactions that are going on within the database. We have the inbuilt security, so like the role-based access controls. We also have the metadata, so we can see like all the objects, for example, like what tables, what databases are there. And then we also have the ability to share data, so we can share our own internal tables with other Snowflake accounts. So to get an idea of Snowflake, I look at this as there's all these different flakes. So we have one flake where we've got some semi-structured and structured data being loaded by an extra small compute into our data warehouse. So this is a Snowpipe loading data. They then have another flake going on, so some more transformation. We have some data transformation doing some read and writes. And that's using a little bit bigger compute, a smaller compute. We then might have, for example, a finance team that wants to get the centralized data and wants to query some financial reporting. So we have a bigger compute on this flake going on, and they're just reading data out for reports. Then another flake where we have this data science team, and they're running like fitted models, and then they're pushing data back into the database. And they again have another bigger compute service in this flake. And then the usual where we have the BI team who are running BI dashboards and BI applications, and they're just pulling data, running the same sort of queries. It's Monday at 9 a.m. So you see Snowflake gives us this centralized storage, the ability to have different computes and different processes going on at the same time. So all the services are wrapped around this, and the storage and compute are separated. So Litzing, did you manage to distribute that? Does everybody has the scripts? So a little bit of background on the story, if you've not already saw it. We're going to be working with a data set which is based off a city bike share. So they're a company in New York, and they want to understand the trips data of the bikers. And we're going to load some CSV data surrounding them trips. And then later on, we're going to load some weather data and see if there's any correlation between the trips and the weather that these riders are undertaking. So we're going to load the weather data, will be an open source weather data set, and it will be some JSON data. So first, let's go into our trial account that we should all have and log in. Let's log into our test account and have a little look at the GUI and understand some of these icons in the top ribbon. So what we have here, top left, is databases, and in here we can see all the databases that our account allows us to, and we have the ability to create new databases, clone existing ones, drop and transfer ownership. The next icon is for any data shares. So we might have some external data shares of our internal tables to other Snowflake instances, and this is where we'd create those. The next place is the warehouses, and this is where all our compute resources are stored. And you can see here that we have a list of different warehouses, and we again have the option to create a new one. We can configure existing ones. We can suspend warehouses that are currently running, and we can resume warehouses that aren't running. We can also drop and transfer ownership. And then the next icon is worksheets. So if you've worked with a lot of databases, you're probably used to seeing this sort of IDE. So on the left-hand side, you have your databases. So you can click through, see the schemas that are in them. And on the right-hand side, you have all the worksheet where you can write your SQL. The little snag here, the little difference, is where you can set the context of the worksheet. So you might have access to different accounts, different warehouses. So within your worksheet here, you can set how you're wishing to compute or execute this worksheet. And then we have the final icon here, which is the history. And this shows all the metadata of what's been executed on this instance against what databases. And what you can do here is you can add filters to look at was there a particular user, was there a particular warehouse. You can look between the time range. And all this is available in the GUI, but this is also available in metadata in Snowflake. So for example, you could create a dashboard off them tables and present it back to the business. A good use case for that is when you have like ETL loads and you might have SLAs. So you might choose to look at the metadata, create something in a BI tool, and present it to the business. So let's start with the exercise. So what we can do, if we click Snowflake, we're now going to run them scripts. So firstly, what we need to do is open them scripts. So on the right hand side here, we have the ellipsis. If we click that and load script, and then if you navigate to the lab scripts that what Litting just distributed, we can open that load script. So just a few house rules whilst I run this. Please can you ensure that this all queries is not ticked, else that will execute all the scripts that are in this worksheet and you would have completed the whole exercise without learning anything. So please ensure that is ticked off because we want to talk about all the different scripts through this worksheet and not execute everything, else you'll learn nothing. And then another rule, this is up to you if you wish to do it. The way I operate on this is I have this highlighter on, so you can see on the screen that I'm running this part. And to do that, if you also click on the ellipses, you have this highlight. You can see I can turn mine off because it's on, but you can turn that on if you wish. That is entirely up to you. That might help. Okay, so let's start with the demo. So I guess the first part we're going to talk about is prepping the data to load. So there's various ways you can get data in Snowflake. You can use the usual sort of proprietary ETL, ELT tools to load data. And what we're going to do here is some manual steps. So we're going to copy using the copy command from a stage where all of our CSV files are. Then you can also have the Snowpipe, which automates that process and loads data continuously. And then there's also external connectors. So for example, like a Python connector. So the data that we're going to load here is going to be CSV files. There's 61 million rows and it's around 1.9 gigabyte compressed. So firstly, let's go ahead and create this new database. So how do we do that? Let's go into databases. Let's click create. And here we are spelling city, C-I-T-I rather than C-I-T-Y. So ensure that we spell it that way. So we create a database called City Bike. So this is where all our trips data is going to be stored. Notice here that we can just click the Snowflake, blue button, and it will take us back to our worksheet. So now we're going to create our first table, trips, but what we need to ensure, as our worksheet is context dependent, that we have our new database selected, as now we have our sysadmin role, our compute warehouse, our database isn't selected, and our schema isn't selected. So let's do that. Also, if you could ensure that we're running this in sysadmin, because we're going to come back to accounts later and use account admin accounts. So we're going to do all these scripts for now in sysadmin. So,
do I have to select the new database?
Yes, you will. So let's do that now. So if we change this to our new database, CityBike, as so. So now we're ready to create our new table. And I guess it's also worth mentioning at this point that Snowflake doesn't charge for any DDL. You only get charged for the DML. So creating all these new objects is entirely free. So we're not going to use, we have a warehouse selected here. It won't actually work, it won't actually run, and we won't be charged for anything. So let's go ahead and create this trips table. So it's successfully created, and we can go and check that by then going into our databases, clicking into our database. We can actually click on our trips table, which we can now see, and then Snowflake shows all the metadata for us. So we can see all the attributes that are in that table. So let's then click the blue and take us back to the worksheets. We now have created a trips table that we're going to load the data in. The next step is to create a stage, and a stage is where all our files are that we're going to load. So to do that, we have the script here, but I want to show you how we can do that using the wizard. So if you will, could you copy everything that's in the double quotes, but not the double quotes? So the URL. And then we'll go to databases. Yes.
Next one is 3.2.4 on our script.
Okay. So you've not. Fine. So I guess that have you created the stage in your 3.2.4? I guess.
3.2 is missing.
Okay. Right.
Two ones are missing on our script.
But does it have the? I'm guessing it's creating the stage because we need to create the stage to load data. So I presume that step's there. But I can show you this anyway. So the way that you could do it is within the wizard here. You can click create, and it prompts you for where's your file store? Like where is your stage? Is it in Amazon? Is it in Azure? Also now is it in Google?
Send the script because they're missing creating the stage, and the next one is missing from the scripts they have. So it's not the same version than you have.
Okay.
So would you
These two lines are missing.
Yeah.
So if you just email these two, then it will. Or
I will send this to
Okay, yeah.
living and living forward.
Because it will be hard to follow without them.
Yeah. But these scripts I have here are like annotated by me. But the ones that we just downloaded, I guess for some reason. Yeah. So,
but it will be sent.
Asmo, which ones are you distributing? Do you want? Is it better if I distribute this and then everybody can use what I have? Because I've got my own annotations on here, so that might be pretty useful. Let me do that. So I'll distribute it to Listen, and then we can go from there. So I can just quickly recap. So we're prepping the data. We created a new database, CityBike. We've created a new table, trips. And then the next thing we're about to create is a stage where our CSV files exist for our trips. So does everybody have the latest scripts?
Yes. And now we execute this 3.2.
You can, but I'm just going to show you on here. You choose to do that, but there is actually a manual way you can do it. So let's see if I copy the URL here. and then I go to databases. I have the option in here, this is all wizards, that I can create the stage. So if I click create, we're actually loading from an S3 bucket, but you can see here that you can also use Snowflake managed, Microsoft Azure, and also I think Google is there now. So we click, oh, not cancel, Amazon next. And now we have a wizard. So in our S3 URL, I actually don't want the single quotes. So if you've copied the single quotes like me, you can remove them. And this is the URL that we'll use. And then we can copy the city bike trips. And this is what we actually want to name the stage. And I can get rid of these because they are not needed. And then the names, we actually need to remove the hyphen because when you name your stage, it doesn't allow you to have the special character hyphen, so we need to actually put an underscore. So essentially, this is what we're looking to create. We have a new stage, we have the URL where the files are stored, and we would create that. So there's two ways. We can create it through a script, or we can create it through a wizard. So now we can go back to a worksheet. And now we can use this list to query a stage and see how many files are there in our stage. So we can see that there's 376 files. If we just expand this a little bit, we can see all them different CSV files, so all them trips files. So we've created a stage. The next thing we need to do is create the file format, so define what them files are that we're loading. So it essentially just sits on top of any sort of blob storage. So we have like our S3 buckets or our Azure blobs, and then you can just sit your stage on top of that and query the data. So it's almost like conceptually like a data lake almost. So you can query the data and query it on the fly, or you can also copy it into tables.
So for example, when we have this list command, we can see that they are like GC files in that stage. So you can see the files now that are in the stage, and we are loading those files soon.
But the next thing we need to tell Snowflake now is what the files are. So for example, we have the CSVs. We need to say, are they comma delimited, which they are because they're CSVs, and in this instance they're actually double quoted. So we will do the same thing again, and we'll go through a wizard rather than running the create script. So let's go databases, file formats, create, and our file format, as we just said, is CSV. And you'll see here that there's all different formats which are supported because we have all sorts of different data types that come in from like IoT hubs, for example, where we might have some JSON data, some XML data. We might have some compressed data sets like Parquet. So Snowflake supports all of these different file formats that you have in your blob stores. So we want CSV, and the column separator will be comma. And in this instance, our CSV fields are double quoted, so we need to select double quote. And then if we can just delete from the null string because we don't need anything in there. And then we can hit finish. So then we can head back to our worksheet. And essentially now we've just prepped, ready to load the data. We've created a new database with the trips table. We've created a stage where our CSV files are. We've actually looked how many CSV files are within that stage, and we've defined the file format of them CSVs. So now we need to move on to loading the data. So now we'll have a little look at examples of compute resources. So for that, we need to look at warehouses. So if we click on a warehouse, and you'll see that we have the ability to configure a warehouse, but the icon at the minute is not highlighted. So let's choose this compute warehouse. I assume that we all have that. Yes. So if you highlight it in the blue row, that then enables this configure icon. So we can click that and click configure. So let's talk a little bit around what these sizes are. So essentially what we have here are different t-shirt sizes, extra small to extra large. 1 credit essentially means 1 VM, so one is your VM or one AWS EC2 instance. So the bigger your t-shirt, the more compute power. And then we have the ability to auto suspend. So I have a warehouse, I want it to suspend after an interval of time because I don't want to be charged for it anymore.
So if there are no one logging on database on 5 minutes, it will shut down.
After the last time it was executed.
Okay.
So this is just a compute resource. So let's say that we've just ran a query using this warehouse and then it's finished. After 5 minutes I can tell it to stop running and I will not be billed for it anymore. And then we have the auto resume. So you could have a warehouse, for example, which just execute ETL loads. So we know the ETL loads are going to start at a certain time in the morning. So we don't want to send that back to sleep because we want it up and ready to carry on doing other data loads. So that's a really good example of when we might use auto resume. And then another thing that we don't see here because we're in the trial account is this multi-clustering mechanism. It's actually in your demo scripts, but you need the Snowflake standard edition, and what that actually allows you to do is create clusters of these t-shirts. So essentially what you can do is you can have at least, well, at max you can scale this 10 times the t-shirt. So if you think we've got 128 VMs there in one cluster, we can actually scale that out to 10 times 128 VMs. So you can imagine that's a lot of compute power in one place. So that's what Snowflake allows you to do. And again, that's just at the click of a button. And if you compare that to, say, what you need to do with an on-premise solution, an on-premise solution really doesn't have that ability. It's scaled to whatever its default capacity is. And then also, if you look at sort of cloud tools that are data warehousing tools there, maybe they're scalable, but they're like an elastic band. They can only scale so far, and Snowflake is like multiple elastic bands. You can scale it for whatever you need on demand. But hey, so now we know we need to use this compute power. So let's, for now, set this to a small warehouse, and then let's load some data. And let's see this in action. So if we set that to small, and if we head back to our worksheet, we can see here's the copy command. So we're going to copy data into trips from our stage using our file format. So let's click run, and as you can see here, we have the compute warehouse as small because we just changed it. We click run, and we can also toggle this open history here, which gives us the status of the transaction. So you can see that it's been running for this amount of time, it started at this time, and we can also watch the number of rows. So we know, for example, there's 61 million rows. I think that's at 24. So essentially we've just loaded data into that trips table. That took 31 seconds to load 61 million records. So that was pretty quick and pretty efficient. But now let's just demonstrate how easy it is to scale this workload. So now we can just run this in a larger warehouse. So let's truncate the table. Then go to our warehouses. Go back to our compute warehouse, click configure. Now let's scale it up to a large. So you can see now that's 8 virtual machines. Now if we go back to our worksheet, clicking the Snowflake button, we can run the same command. We've just scaled our warehouse. We can see in the context here that this compute warehouse was originally small. We just, at a click of a button, scaled it up to a large. Now let's run. We can also monitor on the right hand side the performance and see if we get any performance gains. So it was 31 seconds with a small warehouse, and it was 10 seconds with a large warehouse. So that
you have to trunk it down before you can scale it up. Warehouse.
No, you don't need to, but this is just to demonstrate that we loaded data into the same table, and then we're just going to do exactly the same transaction again, but we scaled the warehouse up. So when we ran it first time, it was a smaller warehouse. So we logged the first load, which was 31 seconds. Then we truncated the table, scaled the warehouse up, and did exactly the same thing, and we saw the performance gain. But you can scale your warehouse up at the click of a button.
Yes.
So another nice feature of warehouses is they allow you to set this context of, you might have a user group, like for data scientists, so you might give them a compute resource just for them. And then you might have a BI team who just run the same sort of BI applications or analytic workloads. You can set a compute resource for them. And that's pretty good if you're an admin as well, because it means you can monitor or allocate the resources that them users are using. So you might choose to like budget by that, as an example, and that way you can sort of fine tune it. So what we're going to go and do here is, now we've created our trips data, and we've loaded some data, we actually want to pretend we're an analytics team, so we're going to create an analytics warehouse. And that's what this script does here. Oh. So we've created an analytics warehouse. We can go in here and see it. So we've just created that in a script. It's a large warehouse, and it's going to be used just for BI reporting applications. So in this next demo, we're going to go ahead and do like some mock queries as if we were running things in a reporting application, and we'd use this analytics warehouse. So let's ensure that we're in the right context. So you can do what I did there if you've not already, and you can highlight rows and you can run multiple queries at the same time. So we want to change this to the analytics warehouse, and we're going to be querying data from our CityBike database. And we can actually close this performance now. So let's have a quick discovery of our data that we just loaded. So here's the first 20 records. And what can we see? We have some start and stop times. I think we have some start and stop longitude and latitude points. And then we have some like characteristics of the people, like gender. So from there, as an analytics function, we might want to do some more querying. So we might want to look at things like the number of trips, the average duration spent on them trips, and also like the distance covered. And we might look at that by hour to get a better understanding of when probably our busiest times on these on our bikes are by the customers. So what we can do here is we can run a query like this. If you haven't ever seen this have a Sine function, this is a neat little function where you can look at and work out the distance between two lat and long start and end points. So in this case, we've got a start latitude and longitude, and we've got an end latitude and longitude, because these trips started somewhere and ended somewhere. So let's run this query. So if we look at this given day, we can say that the early hours of the morning, there were very little trips. Then as the morning approaches, the trips are more frequent. We've got a higher number of trips. I guess that's what you would expect to see. There are going to be less people using bikes, you would have thought, at 4 or 5 in the morning compared to 4 or 5 in the evening. But also sort of a benefactor of having a warehouse just for queries that are continuously used and continuously or like frequently used queries is Snowflake has this results cache where any queries that have been ran in the last 24 hours are actually saved to that warehouse. So that was pretty quick query anyway, but what we can do is we can look at the history again, and you can see that ran in milliseconds. But we can run this, and because we've used the analytics warehouse, it's a common query, it's going to get run by multiple users. Let's run it again. 58 milliseconds, a fraction of the time. And again, that's one of the services that Snowflake uses because it has this inbuilt performance tuning, and you can see there how it works. And then I guess let's have a little look at our trip data and see when did the most trips occur, what month did they occur. So it appears that the busiest period, the busiest month was June. And then we've got a couple of the fall months, another summer month, and unsurprisingly here at the bottom, it's the winter months. I guess people don't like to go out in the cold, but we shall see when we bring some of the weather data in and see if there's a correlation between the weather and these trips. And then also a pretty neat function of Snowflake is the ability to clone objects. So you could clone a production database and it would take a snapshot of what that is with all the data in it, and you could develop that personally on your local Snowflake instance. For example, here we've created this trips table. I can create a clone. And then if we navigate on the left-hand side, what we have is the trips table. And if we look on the trips dev, we have exactly the same table. So it takes a 0 copy of the metadata and a snapshot of the data in it at that point in time. So again, that's a pretty neat feature if you ever needed to like test something and you needed like a snapshot of some objects from production. And you could just take a snapshot of what happened yesterday and then check something out. So sort of recap on what we've just done. We prepped some data for loading, we loaded some data, and then we did some querying of that data. And then the next thing we're going to look at is semi-structured data in Snowflake and bringing in some weather data. We want to further understand, like, is there any correlation with these trips and the weather that occurred. So let's create a new database. And again, let's run all these, and we'll change our warehouse because we were originally running an analytics warehouse. Now this is us doing our admin. So let's change that to a compute warehouse. So again, we can do it here. We could do it in the context if you wish. So I have the rows highlighted. Nope.
Why do you need different warehouses? I mean, if it's just a compute resource, if it's just virtual machines, why can't you use the same?
Well, I think one of the benefits of it is if you've got functions within your business. So let's think about, you've got a data science team, you've got a finance team, you've got a reporting team. You can actually allocate the resources to them teams. So it's also a good way for administration. Rather than just having one warehouse, the ability in Snowflake is to have all these different compute resources, all these different warehouses. They can be in all different shapes and sizes. So you get this scalability and this like elasticity. So you might have, for example, a warehouse for ETL, and then queries start queuing, then you can just scale that warehouse up at the busiest periods if you need to. But then you could...
Yeah, but if you don't have that complex operations, then you could just do it with one warehouse.
For sure you could, yes. Yanni, did you? Sorry,
Yeah,
I see.
an aspect in this, what I realized also with some of the companies why they really like that feature, besides what you already told, is that is the billing side. I mean, they like to see what people use it within their organization, and sort of send the Snowflake bill accordingly. They see that finance is using exactly this much. This is what they will pay. Marketing will pay this much, production, etc. And that's been very favorable feature in that sense also. That's another perspective, but very important because so far companies have not really known the internal billing, how to bill.
Yeah, I think it's again to touch on that. It's been an issue in the past working with like other database systems. Like how do you actually allocate them budgets? So actually having these individual warehouses and knowing who's using the most resources, it's a good way to allocate them budgets and manage it.
Do you also pay for the storage of data?
I don't think the storage is charged, is it, Yanni? You can confirm.
Yes, storage. Yeah, there's. Let's not go into a full pricing thing.
Yeah.
It's very simple actually. We price for two things: storage, but that's just we're surpassing the bill we get from AWS, Google, or Microsoft.
Okay.
And if you have a contract with us, it's approximately $23 per terabyte per month. So that's
Yeah.
that's like really cheap, but yeah.
Yeah, and the billing is per second with anything which is compute in Snowflake. But I think anything related to the billing is probably better to speak to Yanni or any of the Snowflake guys afterwards, or BDS guys. So yeah, if we just move on, and we've now created this weather database. We're in our compute warehouse, and now we want to load some semi-structured data. So what we can use in Snowflake is this object called variant, and it allows us to load semi-structured data without defining a schema. So we can load the data as it is, the semi-structured data as it is, as an object. So we create that, and then we can also create the stage where these JSON files are. So similar to what we did with the trips, when we had the CSV files, there's another stage where the JSON files are. So another S3 bucket. So we can run that, and we can then have a look, list these files as we did the CSV. And we can see all the different JSON files here. So similar to what we did with the CSV files, we're then going to copy the data into our newly created table from our stage with the file format as JSON. So we can run that. And that has copied all the semi-structured data into that variant data type. So let's actually go and see what that looks like in the variant data type in the table. Just give this a second, hopefully it comes around. So we can click on our variant property, and here we can see our whole JSON object. We can see all the key values, we can see nested arrays, we can see hierarchies at the bottom here, if it scrolls. I wait for my laptop to respond. But essentially we've just loaded that JSON object into this variant data type, and you can see that it's kept all the original object levels, hierarchies and key values. So the thing that Snowflake allows you to do easily is actually focus on, focus on just getting that variant or getting that semi-structured data in, and then you can use the native like lateral and semi-structured functions in Snowflake to actually normalize it. Let's bring this back to life. Okay, so where were we? So now we've created the table, we've loaded data, we've loaded the semi-structured data into the table, and you'll see here that we're going to create this view, and in the view we have all this dot notation, which allows us to unpack our JSON object. So as I was just describing, that the focus with Snowflake is you can land that semi-structured data in a data type, and then you can use all Snowflake's native functions to flatten that data and normalize it. And I think in the past, that's been a real hardship for myself in databases to actually flatten JSON. It's never been out of the box and straightforward. But you'll see here that it's pretty easy. So we'll create this view. Does not exist. Did I create that? Sorry, it did this in the incorrect database. Yes, there we are. So we create the view. Bring this up so you guys can see we've created the view. And a nice thing about the view is it hides all of this logic. So when we have users that actually want to just access this view, for example here, we want to look then at these actual points that we've just normalized in the view, and we can select this August, for example here, or a month to look at observation points. All the user sees is the normalized data. So you can see what we just achieved. If I can scroll this up. We landed the data in a variant, and then from that variant table we were able to unpack that semi-structured data using the dot notation, and we now have this view that all users can use to show weather points. So we have all different observation points here in New York for a given month. So we have now weather data. So now we can look at the correlation. Is there a correlation between the trips? Is there a correlation on are people taking trips when the weather's a certain kind? So we've got the semi-structured data and the structured data both centralized in our different databases. Let's now bring them together. So here we have it. We can see that the most trips occur when the weather's clear, or when there's clouds and when there's rain. But then the least seem to appear when the weather's more sort of abrupt. So we can see like thunderstorms, smoke. I think smoke's quite similar to smog. So usually it's when there's like air pollution. So people tend not to go on trips then. But this gives us like a very quick insight into how the trips occur. And that's just by going through this exercise, and when we've just inserted some trips data and some open source weather data. So that's the beauty of having everything centralized in Snowflake, that we can create things like this on the fly. So the next part, we're going to touch on this time travel function in Snowflake. If there's any sort of DBAs in the room, you can remember sort of backups and restore and maintenance programs for your databases. Snowflake takes a lot of that away. So let's get into this. Here's our table that we just created for weather data. Let's just drop it. So it's deceased. Let's check that it's not there. It isn't. We can't select from it. But then we have this pretty cool undrop feature, and we can just revert that.
How long does it take?
It's
How long does it remember this?
this is,
One session or?
I
I think for the undrop it's instant, but for the time travel, Janne, do you know?
90 days.
90 days.
Yeah, so that, I mean, again, we don't have to go into that here, but that releases a lot of backup solutions to companies.
Yeah, sure.
It's
So-
a really big benefit.
So you are able to go in any point of data in the last 3 months.
Yes. Yeah. Yeah.
Any point of data.
Yeah. It's really neat. Like if you've ever been a DBA and you've been through this pain.
Easily, can you see easily those dropped labels then also?
Yeah. Well, you can query. We're actually going to go on to it. You can query the metadata, which is all stored. So you can look at like a session, for example, the session here, and I can see all the update statements, so the errors that I made, and I can revert back, which we'll see in this next part, before that error was made. So we can revert back to a point in time when things were okay in production, so before I made a mistake.
You might have GDPR problem here with 90 days.
So let's go and make that mistake. So it's Monday morning. You forgot that you thought that you was in dev and you were actually in production, and somehow you had the privileges and you updated this table. So this is our trips table, and you set all the stations to ups. That's 61 million records. So you can imagine alarms go off, the business users contact you, why is this saying this, why is it saying that? You're already like packing your things and about to leave the company. But that's where we can actually revert to then a point in time. Let's check the data, let's look how big the mistake was. Yeah, all 61 million records. So there's a couple of things going on here in this query. This is looking at sessions executed by me in this information schema. So Snowflake has all the metadata, all the transactions that have gone on. So I can actually look at what queries have been performed by me. And I can look where the last update occurred. So I just ran an update now, that was the last update. And I can assign it to the query ID. So what essentially I'm doing here is looking for my mistake. And then I'm going to use my mistake in the next query. So let me assign the query ID where I made the mistake. There I go. And here's the real neat stuff. So we can use this create or replace table. It's called CTA in Snowflake, where you can create or replace from any source select query. But what we're saying here is create or replace our table trips and select from the table trips before my mistake. Yes, before I actually made my update. So restore to a point in time before I broke everything. So let's run.
This query text, is it case sensitive?
For Snowflake, no. So what this will do, it will take my query ID, which was set in the variable, and it will save me from being sacked. And then we can go and check the data. Peace and harmony is restored. Fantastic. No backup or restore process. But that's a really nice, like if you've ever been a DBA, you probably know these things occur once in a blue moon. So it's nice to know that these things are there. So the next thing that we're going to talk about is role-based access, and that's the way that all security and roles are governed and users are governed in Snowflake. So to do that, with our sort of story of City Bytes, we have a new guy that started, and he's a junior DBA, and we don't want to give him all the permissions. So how do we do that? Well, we need to be in our account admin, because our account admin has all the sort of security permissions. So that's our account with the highest privileges that can grant all these roles. So we make sure we're in that. Then we create a new role for Junior DBA, and that's what we're going to assign our user to. So you have my scripts here, so you'll probably need to change this to whatever your account name is set in the top right here. So mine is my name, but what we're essentially saying here is, for my new role I've just created, I want to grant that to a user. So I want to grant that to myself, because a user can be granted to many roles in Snowflake. So did I run that? I can't remember if I did, but let me run it again. So you'll see I'm in account admin. So if I refresh this, I can see everything, because account admin has all these privileges. But now, if I switch the context to my junior DBA role, you can see that the junior DBA has only inherited the permissions of public, which account admin had granted to any user at the start. So now we need to give them some elevated rights. So we want to grant usage on our newly created databases because we want this junior DBA to actually have usage to them. So actually, I need to ensure then I'm an account admin because a junior DBA can't give himself permissions. So ensure you're in the right account admin. Then the account admin can then give this role some new permissions. So the account admin can then allocate. So now, if I switch to junior DBA, run, and then I refresh here, I guess it has, yes. As I've granted usage, the DBA can see the information schemas. Now, I might choose to add some more rights, so I could grant usage on the schemas, I could grant usage then on the tables on the schemas, and the junior DBA could have all them permissions. So that's in general how the role-based access works. You can grant this like different actions, so select ownership, updates, and they can be used for all different roles. So it's actually quite a nice way of how you manage your user governance, and it's all just through creating different roles and assigning your users that way. So your roles then are created permissions on objects. So finally, let's talk about data sharing. So we touched on it earlier. So this is the ability to share our internal tables with other Snowflake accounts and then potentially other external users. So there is only ever one copy of the data, and that is the data provider. So for instance, if I was the person that was giving the data out, then the data would always reside just in the one place, and that's on the data provider's instance. The data is always live, and then just to note that the data sharing currently is only supported between accounts in the same Snowflake provider and region. But let's see this in action. So we can create a new share. So let's ensure that we're in account admin role up here, because what we will see is there actually are some shares already created in your test environment by default. So here we have two inbound ones which we're using, which Snowflake provide in the test environments. So we have our account usage, so all our metadata that's shared by Snowflake, and the database is Snowflake. We also have some sample data sets which are coming from this SFC samples, and then a Snowflake sample data. So I don't know if anyone's had the opportunity to play about with them databases. This is where they're actually coming from, a share. So what we're going to do now is we're going to play with a scenario that we'd like to share our trips data or our City Bikes database with a potential client. So we're going to create a new outbound rule. So we can call this City Bike share. We can choose the database, which is going to be City Bike. And I just want to share the trips. I'm not going to share the clone because I want to share the actual production data. And we can click apply. So this would be the table that we will be externally sharing. And we can click create. And then we know what this is going to look like from our preview of the data because we've worked with it. But over here, this would be the instance that the external provider would use. So over here, the consumers is actually what they're called. So we don't actually have this information, but in like a practical world, you would have an account for the consumer on your instance. So there'll be another Snowflake account from somewhere. And you can give them reader or full access to the table. But this data sharing, I don't know if you've ever tried to share data before in other database systems. There might be like some extract part of it, or even setting the security up for it is a real hindrance. But Snowflake just allows you to select what tables you wish, and then you can just give access to another Snowflake account just by adding that consumer as a user on your machine. So I think that brings us to the end of our demo. We can show the billing, yes, to give you a general, a better idea of how it works. So I think we were talking about the warehouses earlier, actually. So there's the administration portal. Well, actually, we can do it through here. There's different ways. But for all the compute resource we've used today, we can actually monitor the load times. So let's say we were talking about when you might have different warehouses. So say we have an ETL warehouse. We might want to see the peaks and troughs of when that occurs. Because if we're always hitting a certain threshold, say we were looking at 2 weeks and was always hitting a threshold at 9 a.m, we might choose to then scale the warehouse up to a bigger warehouse.
If you share data with some supplier or customer,
yeah,
you will be charged if he or she use your data.
I don't know that one, Yanni, do you?
The quick answer is yes, but it's also something that the customer can monetize and agree with whomever they share.
Okay.
For example, companies who actually make money with this option, they share it to all the consumers or all the B2B customers, and they charge for it. So actually they finance perhaps even their whole Snowflake investment
Okay.
with this option.
So it can almost be your own product, I suppose. Yeah. Okay. So you can monitor warehouses like this. I've certainly used this in the past when we've had a BI warehouse, and we've then suddenly on Slack we get all these notifications that dashboards aren't working, data's not loading. You go in your warehouse straight away and you can narrow it down and you can see, wow, the warehouse is being killed here, we need to scale it up. So it's being throttled. So this is a really nice way of looking at that, and you can then, a click of a button, scale the warehouse up. But what we can also do in account, seeing as we're in account admin, we can administer. So here our warehouses are, and I think Yanni touched on it earlier about the billing. So you have this allocation here where you can see the credits that are used by which warehouse. So you have different functions. You can almost start this budgeting, and you can say, this team are spending the most. Should they be spending the most? You get the daily breakdown on your right. You can download this data. Is there any other real relevant things in here? I think this is just a pretty nice way to give you an overview if you're the account admin, to have a look at who are your main consumers. Is there anything you'd like to add, Asmo?
Maybe just quickly show that we granted usage on databases and schemas from the worksheet, but you can also do it from here.
Yeah.
So
Interesting, sorry to interrupt, but interesting that I think we did about the same things with Hannah, but she's more expensive than me.
We do segment our customers.
Okay.
So if we go into the account, if we go into users, not my users, roles, we can create a new role in here. I don't know, senior DBA. And that can be security admin. And then you can give additional grants in here. And then here my users are, so I can add myself as a user again, so I can then be part of all these different roles. I have all these mock users that I've created. and this is just doing the same thing. What you can actually do in here is you can edit this, show the SQL, and copy that if you needed to. So that's always a nice way to start. If you wanted to start scripting these things out, maybe for deployments, that can be helpful.
Looking at the database, there were two tables actually, troops and troops dev.
Yes.
Meant for like staging purposes or?
No, what that's actually showing is you can create these zero copy clones. So you can actually create like a replica of that table, and it takes a snapshot of that table at that point in time. So that
automatically done or?
Yes, we did that.
Created.
Oh, was it there?
So I'd say
Like no data is copied. It will only copy the metadata, so it's really fast, and you don't like duplicate the data.
but it's pretty useful if you're trying to take like a point in time and you're trying to do some debugging. So you might take something to your from your production environment to your dev environment, so you can clone objects and then do that somewhere else and try and fix the problem.
I have a question. So if the original data is updated and you need to copy it again to Snowflake explicitly in order to be able to use that data in theories, right?
Do you mean if you're loading it from a stage?
Yeah. If the data in the stage changes, you have new files in S3, for example.
Yeah.
You need to execute the copy command.
Yeah.
Yeah.
You can create in Snowflake something called a snowpipe, so it auto ingests data.
Yeah.
So
What's the latency there?
Well, it's actually serverless, so I think it really depends on your network.
Yeah. Is the use case usually that you do it once a day, or can you do it like many times a
So
minute?
basically, when you use the Snowflake, you are kind of trying to do it like real time.
Yeah.
But it's never real time, like really fast.
Yeah.
So it's pretty good because it's just auto ingesting. I'd say. I mean, when I've worked with it, as soon as the file's landed, it's usually there in Snowflake stage, like 2 to 3 seconds later when you query it.
Yeah,
So,
but then you need to copy it to tables separately.
but you can do that all in a snowpipe. So you can write it in there. So you can actually select from the stage and then copy it into the table. You can actually the same way we did the weather data here. You can access from a stage the raw keys like this. So I know we've already dumped the data in a table here, but we can actually query the stage and access the keys like this and copy them keys directly into a table using snowpipes.
Is the snowpipe available in here, or is it a separate tool? Or?
You create your snowpipes in here, yeah. And that is, essentially it's automating this copy and stage and load into a table. So it's like ELT, because that's what Snowflake's about. It's about getting your data in there continuously, and then you just do all the transformation in here. Because this is all about transformation. It's all about like spinning up your compute and then transforming your data. And then it should be really seamless using the snowpipes.
Are you able to are you able to move data on incremental, so the records which have been changed from last time?
Yeah, you can do batch processing and like delta processing. Yeah, for sure you can do that.
That was actually mine. So, we like master data, we have historized. So we must be able to do that.
Yeah.
Yeah.
And it's the snowpipe as well.
Yeah, you can do it with snowpipes. So I guess just a wrap up, if there's no more questions, just to conclude what we've been through today. Navigating through the UI was the first thing we did. So we got familiar with like the databases, where they're stored, the warehouses, our users, our history when we're running things. We also got acquainted with how to create databases and all these different objects, clones. We also talked about all this centralized data, so we loaded structured and semi-structured data. Then we also talked about multi-clustering, and I would say please read the follow-along document, because that gives you a better example of how that can be used. Because we used our trial licenses, we didn't see all the options, but that gives you some really good insight there. But yes, we did talk about that. And we did some workload isolation, where we also looked at the elasticity and the performance. And then we looked at the instant query performance that you can leverage by when you have you run one query on a warehouse, then when you run it again, it's automatically cached. Then we talked about this way of elastic scaling, so we can have all these different computes and we can scale them up and down on demand. And then we also looked at the time travel features, so no more backup and restores because we have things at a click of a button. And then we touched upon role-based access and the way that it's governed in Snowflake. So there were a lot of the sort of zero to Snowflake features. And finally, thank you. I guess even more Q&A. If you have any questions, I'll be happy to take questions and try and answer them. And I think the Snowflake guys can probably help out with that. But yeah, thank you. Thank you.